but also in devices which have a strong consumer brand, and brand protection is really important. If you build a consumer device and you get hacked or you leak consumer data, the damage to your brand is immense. And large brands are aware of this and see the advantage in taking security seriously and using things like technology such as a TE to protect user data and make this harder to happen. We do see a lot of solution reuse for mobile. A lot of applications have a mobile application as well as an IoT device, and being able to reuse some of that solution is very useful. But there's also a need for a lot of certification. Certification is happening fastest in automotive. It's become incredibly important in automotive. But there are categories of IoT where this is starting to happen, both verticals such as medical, which need to do a degree of certification, but more broadly, there is a lot of call for certifying IoT devices around the world. And we're going to talk more about this in another webinar, but there are becoming security standards which you have to meet to sell your IoT devices in different countries. And using a TE makes it easier to pass those certifications because the security critical parts of your device are now in a more contained and manageable way. The other piece we're seeing is a lot of post-quantum crypto readiness. Again, it's not that the TE magically solves post-quantum, but being a software solution, you can install new software modules to support additional algorithms. Global Platform, as a standards body, standardizes the crypto algorithms that a TE must support, and they have added to that list of crypto algorithms the contenders for the new post-quantum algorithms, which have been suggested by NSC and other bodies. And that will evolve over time. And because it's a software solution, it's a lot easier to prepare for post-quantum. It's a complicated area, but the TE is a really good tool for post-quantum crypto readiness. It's also worth talking a little bit about TEs on unusual devices. So this is a specific project that we did on a very, very small device. This is probably the most extremely small device. So they're roughly $1 devices. These were devices made by Microchip, and they're running ARM Cortex-M, so a different ARM architecture, and they're designed for embedded use. As you can see, they're very tiny chips. They've got about 64K of RAM, 64K of flash, which is about the size of a 1980s 8-bit microprocessor. These are actually 32-bit devices, so they're quite powerful, but very constrained in terms of memory. And we can fit a micro TE onto this. They have Trustzone or version of Trustzone running on this, and we can do conceptually all of the things that we do with a full-size TE onside these tiny devices. Now, IoT, these very small embedded devices move very slowly. Although it's 4 years ago that we first launched this solution, I would still say this is very early days. It takes time for these new chips to be consumed in any volume. So I think we'll see a lot more of this over the next few years. But certainly there's no reason why even the smallest device cannot have a TE and be correctly secured. For the last few slides, I'd just like to talk a little bit about automotive and the automotive future. Automotive is a big growth area, and because of things like WP29 and because of things like autonomous driving, security has been taken very, very seriously. If we look over the next 10 years or so, there's a number of things we're going to see happen. Attestation and trust is probably the first of these. This is the ability for a vehicle to prove to other vehicles and to cloud systems who it is, that it's genuine, that it's running correct parts, that it's running the correct software, and equally to get that same trust from other parties and validate it. One of the challenges you have is if somebody modifies a vehicle, is the modification they make, maybe they replace a LiDAR sensor. Is that LiDAR sensor as good quality as the one that was there before? Is it a counterfeit part? Is it a damaged part? Should it be trusted? And can you trust the vehicle as a whole after this change has been made? So this attestation and trust is something we're seeing an awful lot of discussion of at the moment. It's a big area that automakers are worrying about at the moment. Probably next in the line Again, we're seeing some of this today, but it's going to ramp up, is data privacy. GDPR is certainly, the buzzword that everyone hears about, but there are standards around the world which are equivalent or sometimes stronger than GDPR. And managing user data in a strongly secure way is really important. So people have worried about this already on the cloud, but it also matters in the vehicle. If the vehicle remembers where I drove and makes that information available to the next driver of the vehicle, that could be a privacy concern. So to do this well and to do this without giving a terrible user experience, I don't want to log into my vehicle when I get into it. So to manage my data well and make sure that it gets wiped when I return a hire car, you need a framework for managing user data. And TEs have a long history of managing this sort of problem in mobile devices, and there's a lot of synergies in automotive, and we're seeing a lot more discussions about how TEs can be used to help manage user data within vehicles for data privacy. And that might be very explicit user data, such as where did I take the car yesterday, down to much more nuanced data, such as my driving style and what sort of insurance risk I am based on that. Another area which we're seeing some interest in today, but which is definitely increasing, is IP protection. Software is expensive, and particularly when it comes to AI algorithms, you can invest heavily in, say, detecting road signs, only to find that AI algorithm running in your vehicle and somebody might want to steal it. And proving that they've stolen it is very hard. So there's an expensive asset running in every vehicle. So you want to protect that asset. A TE is a great way of protecting code because you can execute code in a much more secure way. You can make sure the code is encrypted and only decrypted inside the TE, and you can make other measures. So although the TE is not an AI engine in itself, it is a secure place to run things like AI algorithms. And we're seeing that being used today for things like face detection in mobile phones. We expect to see that happen a lot more in vehicles just for general AI algorithms to protect the IP against theft from competitors. And then moving further forward, there is a huge interest in data monetization. If we look at the auto industry, it's fully aware that it's got all of these data points of different vehicles driving around, different people having different behaviors, and there's a huge amount of data there. And vehicle makers can look at Silicon Valley players and see how they have made their businesses based on this data. And they don't simply want to gift all of that data to Google or Amazon or whoever. They want to make use of it themselves. That doesn't necessarily mean our vehicles are going to want to send adverts to us. It could be things like controlling traffic flow to improve cities. It could be improving engine dynamics to make the next set of vehicles more efficient because we have a better understanding of average journey times. There could be many different sorts of use of data. The role of the TE is that it can store and generate data at very high security, which gives a lot more options. It isn't in itself a data solution, but it becomes a secure place to run data applications. And we've done a number of projects. We as Trustonic work with a number of partners to do a demonstration at a recent automotive conference to show how data from AutoStar can be captured in real time, stored securely, and then later analyzed. So there's a really interesting new area, but it's a way out before it becomes mainstream. So in summary, the TEs are really about having a secure place, a robust platform to build secure services. There's almost no limit to what those services can be. In mobile, they are very commonplace and very heavily used. But in automotive, we can see them starting in IVI units and then growing to other parts of the vehicle to allow lots of new use cases, particularly for vehicle-wide systems when a number of TEs work together. The same sort of thing is happening in IoT, but it's slower. IoT is prioritizing security more slowly, primarily because in the past, consumers haven't looked at security as a buy feature, and the regulators haven't forced this upon the manufacturers. Both of those things are changing. So we expect IoT, much like automotive, will start taking security more seriously, but it's probably a few years behind. So with that, I will pause for any questions.
Thanks, Richard. That was great, very informative. And from the questions we've got through, it seems like the attendees thought so too. I know we've only got 5 minutes left, so I'm not sure we're going to get the time to address all of them, but we'll do our best. And any that we don't cover here, then we can follow up on mail afterwards. There's been a couple of themes that have come through. So the first biggest theme was on the HSM and the secure element. There's a few people looking for more information there. So one says, speaking of secure element in HSMs and how they differ to a TE, could you go into more detail about how they are competing or how they can be complementary?
Okay, so I would say, generally speaking, it is possible. The HSM or the SE, its job is to store a key and then to sign or decrypt or encrypt messages using that key. You can do all of that in a T as well. So you could view the two as competitive technologies, but that's really the wrong way to think about it. The reason that somebody chooses an HSM or an SE is because they want some assurance against things like physical attack. So, you know, leave that simple job to the SE or the HSM. It does it very well. What it doesn't do very well is it can't control who has access to it, because by its nature, it sits connected to the CPU, and when it gets a message and say, please sign this message, it just does it. It's what's called a signing oracle. The TE can be used to act as a gateway to validate the request, to say, should I pass this on to get it signed or not signed? And to do more complicated processing and computation. So things like bulk crypto, because it's far faster. So what we're seeing in practice is that people are not throwing away their T or HSM, their SE or HSM, and putting a T instead. What they're doing is they're using the two in combination. They're using each for what it's good for. And so we often see the two used together. There are always examples of people just using an HSM or just using an SE or just using a TE, but the trend is to use both because they have different pros and cons.
Okay, thanks. I think that's clear. The next big topic is on OTA and OTA updates. So we're seeing software over-the-air updating has become increasingly important for keeping devices up to date. Is it easy or complicated for a TE or its trusted applications to be updated?
So there's a number of different ways of answering this. Certainly, Global Platform has standards for updating trusted applications. And there are standards for updating applications running in SEs, which are very similar. These are quite complicated standards, but they are dealing with very specific use cases. The more common use case is, I want to update the firmware running on, say, my Android device or my Linux device, and I also want to update the firmware running in the TE and my trusted applications running in the TE. Now, that's very straightforward because the TE applications are just files stored in Android. They are obviously signed, they can be encrypted files, but they're just files. So any OTA system that can update Android can also update applications running inside the TE. So for an OEM who is currently managing updates to a device by whatever means, also managing updates to trusted applications or the TE itself is equally straightforward. They're just additional files that need to be updated.
Okay, thank you very much. Is there a performance overhead or a user impact if you want to add a TE to a system?
Simple answer is no. So just like in a virtualized environment, the TE runs on the same processor using the same cores. So there is an argument that, well, if you're running in the TE, you can't be running in Android or Linux at the same time. But in practice, if you weren't using a TE, you'd be running that same processing in Android instead. So by running it in the TE rather than running it in Android, it doesn't cost you any more. It's no performance overhead. So in practice, TEs are everywhere. They run at the same speed as as Android or Linux would. And moving an application from Android to the TE doesn't make it any slower. So no, essentially there's no performance overhead. People often say, but what about crypto? Which I was going to do my crypto in my SE, but now you're saying run it in the TE. Doesn't that mean it's going to be slower? And the answer is no, not really, because even today, SEs are never used for bulk crypto. So if you imagine an SSL connection, a secure element might be used to negotiate the setup of that connection, But once that connection is being configured, all of the bulk crypto, the encrypting and decrypting of individual packets, always happens on the main processor. So doing that in the TE just gives you extra security. It doesn't cost you anything in performance.
There is a slight, so another question come in, and it's on the same topic, but it's talking about the performance impact because the TE is taking a time slice from the RE. Does that cause any performance impact? And is there any benchmarks?
There are benchmarks. I won't try and go into them now, but the TE basically runs on demand. You think of the TE as essentially the TE does nothing until the RE calls it and says, I need you to run this. And then it stops. So if you don't use the TE, there's no overhead. If you're using the TE to do 10% of your effort, then it will be doing 10% of the work in the TE. But the actual overhead of switching between the two is trivial. And in fact, there's nothing. So no, don't think of the TE as running all of the time alongside Android and therefore using up some percentage of the CPU. Think of it as running because it's doing a job, because it's encrypting or decrypting message, or because it's displaying secure video. If it's doing nothing, it's taking no resources.
Yeah, okay, that's clear. I think so. We've just hit time. We'll take one last question before wrapping up. The last one is on post-quantum crypto, because this is a big topic at the moment in the world of security. The question is, are we seeing an impact with the requirements that are affecting the TE?
So yes, people are asking heavily about post-quantum. And the other thing that's happening with post-quantum is people are looking more broadly at their security requirements. So whereas in the past, somebody may have said, well, I just use OpenSSL. They're also saying, I now need to think about post-quantum, but also where is my crypto algorithm running? I want to use, I want to run that crypto algorithm somewhere more secure so the keys are protected. So actually post-quantum is becoming a reason people are looking at TEs when they haven't done before. But absolutely, we are finding people asking about post-quantum algorithms, can they run in the TE? And both from a standards perspective at Global Platform, there's a lot of work on defining the APIs and ways to use those crypto algorithms. And we as Trustonic are adding the post-crypto algorithms to our product. You know, and we have some already, we're adding more all the time. So yes, there's a lot of interest in this. Adding a crypto algorithm in the TE is sort of the first level that you need to solve post-quantum. You also need things like OpenSSL to support using post-quantum algorithms rather than using traditional algorithms. That work's happening in the OpenSSL community, and the TE community is working to make sure that, you know, we are working hand in hand. But yes, it's definitely important. It's a hot topic for everybody, and you know, I think that certainly Trustonic and Global Platform as an organization are very focused on this. I think it will be important for all TE vendors.
Okay, thanks, Richard. So I think, unfortunately, we're out of time. There's still a couple of questions that haven't been answered, but we will get back to them individually later today. Don't let the end of the webinar stop you from asking more questions. So you can contact us through any of the channels, email or LinkedIn or wherever you find us. On behalf of myself and Richard and Trustonic more generally, thanks again for taking the time to join and to listen. We hope it's been useful. Hope to see you back for the next one, which is titled Connected Devices, The Hidden Depths. Don't forget to register so you don't miss out. Thanks very much and enjoy the rest of your day.
Thank you.